Good afternoon. As the operator indicated, I am the lead of Ansell's channel marketing activities with the MSc program. I'm joined today by Chancellor Wyatt, who's one of our subject matter experts in the area of chemical protection solutions, and he'll be leading the bulk of our discussion. We're excited to spend a few moments with you all today talking about challenges in helping companies select the appropriate chemical protection solutions for their application. For those of you who may not be familiar with Ansell or our product portfolio, we've been operating for more than 100 years. We provide a full range of hand and body protection solutions that are used by industrial and healthcare workers. Our team includes 13,000 people working in 55 countries around the world who design and manufacture personal protection products that our workers use to protect themselves against a variety of worksite hazards. One interesting fact, Ansell manufactures more than 10 billion gloves per year. And now I'll turn things over to Chancellor to start us off on the subject matter for today's session.
Thank you, David. As David alluded to, my name is Chancellor Wyatt. I am the North American lead for the chemical and electrical glove categories. And today's webinar is going to be entitled, Chemical Protection, Are You Well Informed and Well Protected? The agenda for the webinar is as follows. Why chemical gloves? What factors influence chemical gloves? How to select chemical gloves? And how to properly dispose of chemical gloves once you complete your usage. So let's get started to understand why chemical gloves. So I'm sure everybody's aware, chemical gloves are something that's used on a commonly basis throughout various industries, from chemical manufacturing all the way to automotive manufacturing. But within all those various markets, chemicals exist everywhere. Chemicals from common oils to acetone, toluene, and some harsher chemicals as well. You'll find that despite chemicals being out there, the lack of understanding of the proper PPE to choose is always an issue where different workers are being exposed to these chemicals. And what you'll find is that studies show that 89% of the workers in automotive, metal fabrication, machinery, chemical industries encounter a basic level of oil and grease, which can become toxic to you over time if you're exposed to those respective chemicals. And out of those 89% workers, you'll find 55% will encounter the chemical and have direct contact. And the biggest issue you have is that most times you're wearing the wrong protection because of lack of education and understanding. Most times you're wearing a mechanical glove that may be fully dipped or three-quarter dip, and you assume you're getting chemical protection when in actuality you're not. And thus you're actually getting contact and prolonged exposure, which can lead to different harmful effects. You know, when it comes to dermatitis, you have burns as well as having cancer, which can be life-threatening. So chemicals are there, they're everywhere around you, and anything that you may come in contact with that has a material safety data sheet is considered a chemical. So as we look at really driving into understanding chemicals and understanding how to properly select your chemical PPE, let's truly understand the factors that help drive those selections. So what you'll find is that within the world of chemical PPE, there are various regulatory requirements that must be met. Within the body of personal protective gear, hand protection specifically, you have the EN ISO 374 as well as your ASTM standard. And what you'll find is that there's a lot of harmony between both of these regulatory requirements, but most cases, what you'll see on a glove typically is driven by EN ISO 374. And so within these regulatory requirements, you go into different factors such as permeation, degradation, and penetration, things that most people are commonly accustomed to if you actually go through looking at different types of tools or work with manufacturers around what's the proper selection of chemical PPE. So let's talk about permeation. And permeation is probably the most common term that's used when understanding chemical solutions, understanding chemical compatibility. And we look at permeation, in essence, it's the process of which a chemical moves through a protective glove material. The material could be natural latex, nitrile, butanol, neoprene, and so forth. And what you'll find is that with this type of testing, you're going to actually define what we call performance levels. And these performance levels range from 0 to 6 And what it does, it gives you an indication how long it takes before that chemical will go through that material that you're using as your barrier or your chemical glove per se. And so when you have a red color, which is going to the lower range, you'll find that's considered where you should be more cautious versus where you get to the green where you're going to have a lot more time to work with that particular chemical without worrying about any exposure or any effects that could harm you over time during your application. But I will say that it's very important to understand other factors that do influence permeation, which we'll speak to a little bit later on. But for the most part, permeation is something that's always used in terms of the different types of way you would go about selecting whether or not a glove will fit that respective chemical hazard. So when you look at doing permeation testing, there's going to be a different type of requirement that's used to actually define whether or not a glove is suitable. And what they're going to do is you're going to actually use a list of 16 chemicals, which you see in front of you. And these are the most common chemicals in the industry today across numerous markets, from distribution all the way to chemical. And what you'll find is that, in order to look at complying to whether or not a glove is suitable for that given chemical, you have to be able to at least choose so many chemicals off this list to test against. And based on your test results, you'll define whether or not that glove is acceptable. So let's speak to that. So when you have permeation, you're looking at three types: type C, type B, and type A. And type C says that if you're able to choose one chemical off that list on the previous slide, if that chemical had no permeation within 10 minutes, then you would consider type C. But if you consider three chemicals of any choice of your choosing, and there is no permeation within 30 minutes, then you would be considered type B. And then type A is if you choose any of those 6 chemicals from your choosing and do not have any permeation within 30 minutes, then you would be considered type A. And what this really helps you understand is whether or not that particular product that you're using has a level of chemical resistance. Do not use this as a guide to say that it's only good for a given chemical based on the letter that you see here, where you'll have a letter X, Y, or Z, or it could be a U or a B. Whatever the case may be, how it's donated from the previous slide versus those chemicals that were listed, you should not use this as a direction of saying it's only good for those chemicals. What this says is that the glove that you're using has a level of chemical resistance. It's going to be up to yourself to work with the manufacturer and use different tools that we'll speak to later to allow you to make sure that that particular chemical hazard will work against that glove. But this is the first step in being able to define whether or not you have a glove that's considered chemical resistant as it relates to permeation. Now let's speak to degradation. And degradation is something that most times gets overlooked. And many times we don't really think about it because most of the data that we have to our disposal is around degradation, or permeation rather, excuse me. And permeation is great to use, but degradation really gives a different story. And what it really says is that any contact you have with that chemical that causes a physical change to the product. So the physical change, when it comes to, it can be stretched, it can start thinning out, you can actually see elongation or the material start to bubble over. When you have those types of physical changes that you can see, that means the glove is no good for that particular application against that chemical hazard, regardless of the permeation time. You should not use that glove. And so degradation is really critical, and one of the ways you can look at degradation, if it's not really clear on the understanding, is consider you take a cup, a plastic cup that you drink out of, and you put it in the dishwasher. And when it goes through the dishwasher, it goes through a change, but then when it comes out, it looks deformed. That's what's going to happen when you have a chemical contacting, a given material that's not meant to be, and you'll get the product that physically change, and that's the term in general degradation. And there's two ways of getting that information, through a puncture resistance test as well as a weight change test, where you look at the glove before and then after when it's exposed to that given chemical. Degradation data has to be provided by the manufacturer. And so if you actually ask for this data, the manufacturer will have this data for you to ensure that you are confident with the choice that you're using against that chemical hazard that you're going to be exposed to. And then another area is penetration. And penetration is not always spoken of, but it's really the key. This really defines whether or not the glove is going to be liquid-proof. In terms of being able to say you have a sample of gloves and there's no pinholes. If the glove is not liquid-proof, there is no chemical resistance or chemical protection. And so this is a test that's actually done just to ensure that the glove is liquid-proof. It can be done via water leak test or air leak test. And based on the sampling and what you're able to achieve, this is how you can go into recognizing whether or not the glove can be certified against microorganisms or fungi or bacteria. And then from there, viruses as well, which is ideal when you're going to deal with conditions of cleanup that deals with virus exposures and so forth, like Ebola and the like. And so those are kind of things that you have to go through in order to achieve, the various markings that you see in front of you around microorganisms as well as virus protection. But penetration really is the fundamental base to the idea of whether or not you have a product that's chemical resistant. And at the end of the day, if you don't see the flask that says a type A, a type B, or type C, then I rest assure you it's not a chemical resistant product. And do not use it if you think that you're going to use it for chemical resistance. The key is making sure you have that marking on the glove to be confident that the glove is going to be chemical resistant, but then work with the manufacturer to make sure that hazard you're exposed to is the right hazard in terms of the right glove you're going to use as well, to make sure there's not going to be any issues in terms of using that glove within that application. So now that we have an understanding of certain parameters, things that actually influence the choices, selection around gloves and PPE that's chemical related, let's look at how to properly select chemical gloves. So this is a basic guide. However, there's a lot to really think about. And as I said previously, most times you look at your permeation data and you look at, well, if it says 480 minutes, then I can use the glove and I'll be okay. Well, there's more to it than that. And this is something you should consider as you go about your selection process. So the first thing is make sure you identify your primary hazard, which happens to be the chemical, which is why you're choosing the glove in the first place. Understand if it's a particulate or a biological agent. If it's a biological agent, then you need to consider the fact that whether that glove does have microorganism or bacterial protection, as I alluded to in the previous slide, as well as whether or not it has virus protection. Because some gloves will not be necessarily able to meet that criteria, but some will. So you should be able to really recognize whether or not that's the case. So understand your primary hazard should be your first goal. And then secondly, understand the type of exposure. Are we talking about splash or are we talking about immersion? Many times you're just going to have an incidental splash. And when you have an incidental splash, it makes a difference as to whether or not you have a glove that's going to last for a long time versus a glove that you could use that works well enough within, say, 60 minutes. And that may be sufficient. Even though it's not considered green, it might be considered orange. But because of the type of exposure, that glove will be sufficient for what you're trying to do. So that also goes in line with understanding the length of exposure. Many times, we tend to look at the green on a chart. It says, I got to go with that glove. But many times you can also look at a glove that is red, and it may be okay. And when you look at red, marking within permeation, that's usually considered a disposable glove, strictly for splash. But many times you're going to use the glove for 30 seconds, less than a minute or a few minutes. And that's when the glove might be okay. And so it doesn't mean you have to go with the green, but you can also go with something that's considered an orange or considered a red when it comes to the permeation data based on how long you're going to use the glove. So just be kind of mindful of that, because that will make a difference, because many times you may need to have other types of benefits, other types of secondary hazards being addressed, which is why you need to understand exactly everything around that needs to happen for that particular glove choice. And then the next thing is look at your use conditions. And what that really means too is the temperature. Many times you go into an environment and you'll be exposed to, what you consider a normal room temperature, but then when you're working in a factory, it can be very hot, high humidity. And when that happens, a lot of the data results that you have here are going to somewhat change. It's like looking at a T-shirt, and you have the T-shirt, and then when you stretch it, you start seeing a little bit more of the holes. in the shirt when you stretch it. Well, the same idea. When you have a lot of temperature, material expands. And so you have pores that open up, which allows the chemical to actually get through a little faster. So a lot of your permeation results and so forth that you see from the data that you may get from working with your manufacturer are going to be somewhat off because those data results are all based on working in the room temperature. So if you're in a hot, very hot environment or even somewhere very, very cold, that gives you some varying results. But I will say rest assured, the results are not going to be so dramatic where you're going to be uncomfortable to choose a glove that may be in the green, and it'll probably more likely stay in the green. It just won't be 480 minutes. It may be actually 120 minutes. So it should still be sufficient for you. And then think about your secondary hazards. Do you have thermal conditions you need to be aware of? Hot, cold, static discharge, cut performance need to be addressed. So these things right here are things you need to balance in your whole choice of choosing a glove, and thus why I stated earlier that you may not necessarily go with something that's 480 minutes because some of the other factors you may need may force the glove to be a glove that's going to be considered 60 minutes. But that's appropriate for your application based on the amount of time you need to use the glove, and that's okay. Just understand all the different conditions before you make your ultimate decision for the gloves that you're going to choose. Now, you don't have to be an expert. There's many tools that exist out there that you can get from your distributors, such as MSC, as well as working with Ansell, you can get as well. You have different tools such as a chemical glove resistance guide, which is a hard copy trifold that can be utilized with some key gloves on there that cross various materials against the most common chemicals you can utilize to help in your choices selection to try to give you some guidance so you'll feel confident that you're not going in the wrong direction. But as well, there are online tools that exist. And with those online tools, which you'll be able to see, AnsellGuardianPartner.com/chemical is a tool that's out there today that you can use that's open to the public, and you can go in and put your CAS number or even just type the chemical. And it'll have a selected predefined list of gloves, and you'll be able to get a quick chart right away that gives you guidance and direction whether or not you have the proper type of glove being used. And this tool also provides degradation data. And so that way you can feel confident that you're going to make the informed choice based on having all the factors taken into account in your selection process. So this is just, in a long story short, just gives you a different host of different things you can use to really help you in the event that you're not the expert, and that's okay. Because right now we know that this decision process is not something that you take lightly because it can lead to something fatal in the long run. So it's very important that you make sure you be confident, and Ansell and MSC are partnering together to ensure we provide you that level of security based on the tools that we have to offer, as well as the engagement that we can offer you as well in terms of just us talking to you, walking through it with you, and making sure you feel confident to go into your actual daily job. So once you have your glove choice, and you know what you're going to do, and you're going to do your application, we want to make sure that the gloves are properly disposed of. You don't want to do anything that's going to allow chemicals that may be sitting on a glove be put into the regular trash and then all of a sudden affect our environment. So we want to make sure that you're following the best practices that exist. So when to dispose chemical gloves, one of the things that we always say is, a lot of times people ask, well, can I launder a glove? Can we launder gloves? And typically what we tell people is, the best practice is to wash it down, with cold water or some type of solution, using the appropriate channels as far as doing that so you won't have chemicals that's going to your regular sewage drain. But washing those gloves down, using a damp cloth or something to wipe it off. The reason why we prefer that method is because when you take a glove and put it into, some type of laundering system, you're going to be exposed to high heat. And that high heat, is going to change the glove, the detergents and how the detergents interact with the glove. And then when you do tumble drying, you got more heat there. Those different, steps can actually affect the properties of that material. And so we feel that it's to your best advantage to make sure, that you take a more safe approach by just kind of, rinsing the glove off and just kind of applying a nice damp cloth to try to clean it and then dispose of that cloth in the appropriate container as you're defined by your safety director and so forth. Now, it does not mean that in some critical cases you won't be able to launder. That we just prefer you not doing that in the case of chemical gloves, just to preserve their actual properties of providing the proper chemical resistance. But most importantly, when you do look at cleaning the glove and then reusing it in your next, application, or reusing it the next time you go back to your job, make sure you inspect the glove. Look, see if there's any discoloration. Make sure there's no pinholes. Make sure the glove hasn't changed and things like that. And the reason why is because many times when you clean the glove, if it's not cleaned thoroughly, the chemical that may have splashed on there is still there. And that chemical being there is going to be there, and guess what? It's eating through the glove over time. And so it's going to permeate. And so it's important to just kind of inspect and make sure when you get ready to reuse the glove that it's going to be okay to use, and you look for different signs when it comes to such as pinholes, discoloration, tears, and so forth. And if the glove is not the right glove or something that you want to immediately dispose it using the proper channels that is being outlined to you based on your municipality or the rules that you guys have in place, by your employer. Now, in terms of just general best practice around glove, shelf life, it is ideal that, based on the material, that you should discard your glove after a certain period of time. Typically, you look at, 3 years for certain materials and then 5 years for others. And the reason why that's important is because, gloves will change, over time when it's sitting. And depending on the environment it's sitting in, if there's a lot of humidity, if it's exposed to sunlight, whatever the case may be, gloves can actually change. And so what you don't want to do is have a glove that sits for a long time, and then you pull it and try to use it, and then you wonder why you're getting issues, when it comes to being exposed. And that's really because of the life of the glove and where it's stored and how it's stored. And so it's important that gloves are properly, packaged, are properly kept in a confined area where the temperatures are pretty relatively normal to make sure there's not going to be any issues with that glove not performing when it's time to actually use the glove long term. And so these are just some of the best practices to think about as you look at disposing gloves and reusing gloves, going forward. But one of the things I want to just emphasize is that when you look at making your selection, don't just focus on your permeation or breakthrough times. Think about everything that you need to understand in order to do your job and do it well. That's going to come down to understanding how long you're doing the job, the type of exposure you're going to have, and then also what other hazards you need to look at mitigating. If it's a cut, anti-static, thermal, whatever the case may be, want to make sure that you're properly protected, all the way around such that you can do your job and be productive, but then be able to repeat that job without any issues going forward as well. So in terms of just understanding your selection process, these are the key points I wanted to cover. And so at this time, I'm going to turn it over to Rebecca now.
Thank you, Chancellor, very much, and thank you, Dave, for that introduction. Just want to go ahead and emphasize the fact that MSC really appreciates the partnership with Ansel in bringing you this informative information. In the future, if you have a desire to learn more about chemical protection, gloves, or any other kind of safety-related issues, we at MSC have developed a content educational site called Better MRO. You can find this at mscdirect.com.